Let's move to our next speaker now, portfolio leader, high-value biorefineries from Scion, speaking about opportunities for distributed manufacturing via local pilot-scale biorefineries. Let's hand it over now to Stefan Hill. Tēnā koe, Stefan.
Tēnā koutou, tēnā koutou, tēnā koutou katoa. I would like to thank the organisers for the chance to present to you today. What I would like to present is how biomass, so that's trees and plants and other materials, can be used to transition New Zealand from a linear economy into a circular bioeconomy. We live at the moment in a bit of a blip in history, and we'll call it the oil economy. So oil hasn't been used for well, about 20,000 years of human history. And then we've got this blip where oil has become probably our primary source of energy, primary source of materials. And as time goes on, that oil's going to run out, and we're going to end up very much in the situation we were prior to the discovery of oil, but with all our technological know-how behind us. The oil economy probably can never happen again. That was an artifact of the development of Earth for billions of years. So we're going to have to live with the fact we're running out of oil. On August the 22nd in 2020, we had what was called Overshoot Day. So that's the day where the demand for materials and products and resources exceeded that which the planet can regenerate within a year. So that means that we're running currently on ecological debt, and sooner or later, we're going to have to pay up. Now, you could say that we're improving. In 2019, that Earth Overshoot Day occurred on the 29th of July, but not by much. So what's causing this overshoot? Why are we living beyond our means? Partially because of the way that we run our economies. Our economies are linear. So we make something, we use that thing, and then we throw it out. And that's usually in landfill, and unfortunately can end up in other places where we don't intend it, such as the oceans. Now that model will mean that we're going to come to a state where the planet can no longer support our way of living. So maybe we have to change our way of living. This is where a circular bioeconomy comes in. So what a circular bioeconomy is, really it's taking cues from nature. Nature has a lot of circular processes. There's the carbon cycle, there's the water cycle, there's the nitrogen cycle, there's the phosphorus cycle. All these things have the word cycle in them. None of them have the word linear. So we're going to have to start to take more notice of the way that nature deals with materials, and that's every material isn't a waste product at the end, it's a feedstock for another process. And that's how we make sure that we have society and harmony, society and nature can come together in harmony. And that is what we mean by circular bioeconomy, where all of our waste materials that we generate in the modern world are feedstocks for another process, and that waste is minimized and preferably negated. Just a reminder about, are we waiting for oil to run out? The answer is no. The Stone Age didn't end because we ran out of stones, and the oil age won't end because we run out of oil. It's going to run out because it's the right thing to do. And our way that we behave and the way that we think when we manufacture, when we produce, is going to be influenced by that whole life cycle. What will my product end up being in another 10, 15, 100 years? What this means is changing the way in which we envisage we live. So we're going to have these materials, which are inputs, and these are things that we all are going to continue to want and need: cell phones, electricity, large screen TVs, food. And they're going to be required to be transported into our system, which is our new cities. But within those cities, we need to make sure that we recycle, reuse, recover, redesign, regenerate, and reduce. So that basically means try to keep any material which came into our system from an external producer in the system as long as possible. And ideally, you never have an out arrow which is producing basically waste that we don't know what to do with. So how will we get there if we're running out of oil, or we don't want to use oil because it has negative ecological impact? Well, there's been a statement made that anything made from fossil fuels today can be made from a tree tomorrow. Then I'll extend it and say plants in general. And the answer is yes, it can. So an example of this is from an infographic I found on the web, is the number of industries where products from trees or plants in general can have an impact. So that's aviation, civil construction, printing and publishing, packaging, food, automotive, cosmetics, electronics, and you can read the rest of the list for yourselves. These are all the things which at the moment a predominant number of chemicals and compounds are coming from the fossil fuel industry as a byproduct of making petrol and fuel. So all these things are going to be shifted, will shift in time into coming from plants, and those plants will be grown sustainably, will grow the right tree in the right place. As an example of where sometimes it just actually makes sense to transfer the way we currently do things and generate materials in the petroleum industry into this new bioeconomy, circular bioeconomy, is here's a case of a thing called acrylic acid. Now that's used in the paints. You've heard of acrylic paints. It also, if you happen to wear glasses and they're not made from glass, from plastic, that plastic's likely an acrylate. They're used in contact lenses. It's used in glues, all sorts of materials. Now, currently, we make that, if you look at the slide on the right-hand side, we dredge up oil. That oil, we separate a particular compound. We have to modify that compound in 4 steps to obtain this acrylic acid that we use in our industry. Now, if you look on the left-hand side, we can achieve that same end product, exactly the same chemical. There's no difference, by using plants, and that's only a 3-step process. So it makes sense. Now, why are we not just doing that now? Well, the reason is there's a lot of infrastructure in the petroleum industry, and we need to build the infrastructure in the biorefinery space. So that's mirroring what the petroleum industry does with the oil refineries, but we're going to use biological inputs rather than oil inputs. And that's far more sustainable and also allows us to do things a completely different way. We can look at how we improve our ecological impact when we are carrying out these chemical reactions or extractions. We can also look at what new materials, we don't just have to be stuck with what the petroleum industry gives us at the moment. We can dream a little and come up with the perfect material rather than the material we currently have. So how do we get there? Well, one of the steps is we need to understand the biomass, and that's the plant, and that comes down all the way to its genetics and understanding how we make sure we're optimizing for what we're trying to achieve. And that is a lot of research can then go into phenotyping as well, and then how those different plants, and that's a range of plants, I'm not just talking trees here, can be used and utilized into making materials which will displace in time the current materials we get from the fossil industry, but in a sustainable way. And then at the end of life of these materials, we also have a bit of a think about how they can be used rather than thrown away, say in a landfill, how they could be the input for another factory or another process. Now, the oil refineries tend to be quite big and they tend to be quite centralized, and there's numerous reasons for that. But in a circular bioeconomy, we can rethink that model. We don't need a massive refinery somewhere. What we could end up with is lots of little refineries in the regions, which would be dealing with a particular biomass to produce a particular product. And arguably that particular product could then feed into a larger biorefinery. So we term this that distributed manufacturing, where the plant comes to the resource, or the processing plant comes to the resource, rather than the resource going to the factory. Now, there's an example of that happening in Ireland right now, where they have these mobile plants for processing grass to turn it into various feedstocks for the chemical industry. So what we have a vision is that you'll have your feedstock, and then there'll be some sort of mobile biorefinery potentially, which will just sort of drive around, maybe seasonally. So the vision will be a circular bioeconomy in which the regions play as much of a role in this new way of running New Zealand as will the major cities. So where are we headed with this? Well, it's the cartoon where it says here that that people can't wait for COVID to go away to get back to normal. Well, we sort of believe that this is a chance for us to have a bit of a stop and a think and understand whether what we mean by normal and whether normal is actually what we should be doing in the future. And I'll just close with science strategy is to support New Zealand to transition to a circular bioeconomy. New Zealand can be a powerhouse of a lot of materials which currently we import that can be shifted away, and we can become net exporters of fine chemicals and other materials to the world. Thank you very much for your time.
Thank you very much, Stefan, e te iwi.